Hello friends, welcome to my YouTube channel Ik Onkar Coding. Today I discuss sorting techniques to sort the elements in an array. So first we discuss what is sorting. Now sorting is a process or an operation by which we arrange the data elements in ascending or descending order. For example, we have an array of 10 elements and the elements are 7, 9, 3, 6, 8, 2, 14, 18 and 5. If you analyze, these are random elements. Now after sorting, the elements are appeared in this way. First we have smallest element, then greater element and up to so on. If you analyze, all these elements are in ascending order. Basically, we have different techniques to sort the elements in an array. Like we have bubble sort, selection sort, insertion sort, heap sort, merge sort, quick sort, radix sort. The thing is, we have 7 to 8 techniques by which we can sort the elements in an array. In today's session, we discuss about the bubble sort. So now we discuss which approach is used in bubble sort. Now in the bubble sort we have different number of passes. In different passes we compare the first element with the second element. If your first element is greater than the second element, then we swap the elements. Otherwise elements are not swapped. So first we discuss the technique of the bubble sort with example. Suppose in an array we have 5 elements like 11, 15, 2, 13 and 6. How many elements we have? There are 5 elements in this array. The thing is, if there are n elements in the array, then how many passes required? N minus 1 passes are required to sort the elements using the bubble sort. So here, what is the value of n? N has the value 5. Here n has a value 5. It means how many passes required? It means uh, n minus 1, that is 5 minus 1, it means 4 passes. It means 4 passes are required to sort the elements using the bubble sort. Now first we start pass 1. Now in pass 1, first we compare the first element with the second element. This is our first comparison. So 11 is greater than 15? No. So elements are not swapped. We write as such 11, then we write 15 as such, then 2, 13 and 6 because elements are not swapped. Now we compare 15 with 2. Now we compare second element with the third element. Now 15 is greater than 2. Yes. So elements are swapped. Now 2 and 15 are interchanged. Rest of the elements we write as such. So 11, 2, 15, 13 and 6. After this we compare this third element with the fourth element. This is our third comparison. Now first element is greater than the second element. So elements are swapped or interchanged. So 13 and 15 are swapped. Rest of the elements we write as such. After this we compare fourth element with the fifth element. Now this is our fourth comparison. Now 15 is greater than 6. Yes. So elements are swapped. Only 15 and 6 are swapped. Rest of the elements we write as such. So after completing fast 1, now we compare 15 with, there is no element. Further we have no element. So now pass 1 is completed. The thing is, after completing pass 1, your biggest element placed at the right position. So Now 15 is in the sorted list. Rest of the elements are in the unsorted list. If you analyze, 11 is here, 2 is here, 13 is here, 6 is here. So these elements are uh, in the unsorted order, and 15 is in the sorted order. Now the after completing pass 1, the position of 15 is fixed. The thing is, the greatest element is placed at the rightmost position. This one is the rightmost position. Okay, so if you analyze, in pass 1 how many comparisons we performed, if you count, this is our first comparison, this is our second comparison, this is our third comparison, this is our fourth comparison. So four comparisons we performed, because at the starting time, how many elements we have five elements in this array. That's why in pass 1 we have n minus 1 comparisons. Okay, in pass 1 how many comparisons we performed? N minus 1, that is 4 comparisons we performed. Now after this, now we start pass 2. Now in pass 2, first we write these elements as such: 11, 2, 13, 6 and 15. Now we compare again. Now we compare first element with the second element. Now 11 is greater than 2, yes, so 11 and 2 are swapped. Rest of the elements we write as such. So this is our first comparison. Now we compare 11 with 13. Now we compare second element with the third element. Now 11 is greater than 13? No. So elements are not swapped. So 2, 11, 13, 6 and 15 we write as such. After this we compare 13 with 6. That is, we compare third element with the fourth element. Now 13 is greater than 6? Yes. So elements are swapped. So 6 we write here and 13 we write here. After this, now pass 2 is completed. Okay, because there is no need to compare 13 with 15, because 15 is already in the sorted order. So now after completing pass 2, the two largest element are in the sorted order. Now the thing is, position of 13 is also fixed. Okay, so after completing pass 2, two elements are in the sorted order, rest of the elements are in the unsorted order. Okay, now thing is, how many comparisons you performed in pass 2? In pass 2 we have this is our first comparison, this is our second comparison, this is our third comparison, this is our third comparison. So how many comparisons you performed? We performed only 3 comparison, that is n minus 2 comparison, because n has a value 5. 5 minus 2 is equal to 3. Because when we start pass 2, how many elements we have in the unsorted list? In the unsorted list we have 4 elements. So for comparing 4 elements, how many comparisons we required? We required 3 comparisons. I hope now you understood. So now we move to the pass 3. So now we start pass 3. Now in pass 3, the elements we have 2, 11, 6, 13 and 15. Now again we compare first element with the second element. Now 2 is greater than 11? No. So elements are not swapped. This is our first comparison. Okay, after this, now we compare second element with the third element. Now 11 is greater than 6? Yes. So this is our second comparison. So elements are swapped. So 6 we write here, 11 we write here. After this, 13 and 15 are already in the sorted list, so there is no need to compare 11 with 13. So after completing pass 3, your 3 elements are in the sorted order. Now the position of 11 is also fixed, and left we have 2 elements, 2 and 6. Now we start pass 4. The thing is, in pass 3 how many comparisons you performed? In pass 3 we performed only 2 comparisons, that is n minus 3 comparison. 5 minus 3, it becomes 2. two comparisons we performed here. Now we start pass 4. In pass 4, we have only two elements left. All these three elements 11, 13 and 15 are in the sorted order. Now we compare 2 with 6. Now thing is, for comparing two elements, how many comparisons required? We require only single comparison. So now we compare 2 with 6. 2 is greater than 6? No. So elements are not swapped. 2 we write here, 6 we write here, and rest of the elements as such. The thing is, after completing pass 4, these 4 elements are in the sorted list. Now we have left only single element, that is 2. So there is no need to move to further pass for sorting the single element, because single element is already in the sorted order. I hope now you understood why n minus 1 passes are required to sort n elements, because last element is already in the sorted order. So there is no need to move to the further pass 5. Okay, if you have 5 elements in the array, then 4 passes required. If we have n elements in the array, n minus 1 passes are required. Okay, so now we discuss the code, how to implement the bubble sort. So first we include the header file, that is iostream. After this we include standard packages. After we include main function. First we declare an array A of size 20. N represent the number of elements in the array. I represent the index of the array. Temp is a variable that is used to swap the elements, because in bubble sort we swap uh, uh, the values. If the first element is greater than the second element, we swap the elements. So for swapping, temp variable is required. After this we enter the number of elements. So first we display the message enter number of elements. After this we enter the value of n. After this we enter the elements in the array. So using the for loop, I start from 0, I less than n, I plus plus, c in a of I. Using the c in object, we enter the values in an array of name a. Now the thing is, how many times this loop is executed? This loop is executed n times, because 0 to n minus 1. 0 to n minus 1, how many times? N times. Okay, so here n has the value 5. If you suppose you input the value of n as 5, okay, now 0 less than 5, 0 less than 5, condition true. 1 less than 5, condition true. 2 less than 5, condition true. 3 less than 5, condition true. 4 less than 5, condition true. 5 less than 5, condition false. So how many times? 1, 2, 3, 4 and 5. So 5 elements are entered using this for loop. Now after this, now we write the code for implementing the number of passes. Now after entering the elements in the array, now we implement n minus 1 passes to swap the elements. So now we discuss the further code. Now here, how many times this outer for loop is used for implementing the number of passes. Now this outer for loop is executed how many times? If n has a value 5, if n has a value 5, then how many passes required? 4 passes required. It means how many times this loop is executed? It means this loop is executed 4 times. Okay, so I is equal to 0. I start the index, because index of an array start from 0. So I is equal to 0. I less than n minus 1 means 0 less than n minus 1 means 5 minus 1 is 4. 0 less than 4, condition true. 1 less than 4, condition true. 2 less than 4, condition true. 3 less than 4, condition true. 4 less than 4, condition false. So how many times this loop is executed? 1, 2, 3 and 4. So this loop is executed. This outer loop is executed how many times? This outer loop is executed 4 times. Okay, so this loop is implemented for the implementing for number of passes. Now for swapping, we implement another for loop. So j is equal to 0, j less than n minus I minus 1. So here n has a value 5 minus I has a value. Now the starting index of I is 0. At the starting time I has a value 0. So 5 minus 0 minus 1, it becomes 5 minus 1 becomes 4. It becomes 4 beta. Okay. So 0 less than 4, 0 less than 4, condition true. Okay. Now we write here if condition. Now we compare first element with the second element. Now what is the value of j here? J has a value 0. So a of 0 is greater than a of j plus 1 becomes 1. Suppose you enter the values like first value is 11, second value is 2, third value is 5, then we have another element 6, then we have uh, 20. Suppose we have these elements. Okay, so if a of 0 is greater than a of 1, now a of 0 means 11 is greater than 2. Yes, condition true. So control go inside the inside the if condition. So here temp is equal to a of j, means a of 0 means 11th value goes to the temp variable, and a of j means a of 0, because j has a value 0. At a of 0 what value go? A of j plus 1. At j plus 1 what is the value? That value is 2. So at 0 position which value go? 2 will go. And a of j plus 1 means a of 1. A of 1 is equal to temp. What is the temp value of temp? Temp is 11. So at 1 position means this is 0 index, this is first index, this is 2 index, this is 3 index, this is 4 index. Okay. So after completing this pass sorry after completing this if condition, here 2 and 11 are swapped. Now 5 is here, 6 is here, 20 is here. So these are the elements. So after this, here your if block is closed. After this, j is updated. J becomes 1, 1 less than 4, condition true. So now we compare a of 1 with a of 2. Now it becomes a of j becomes a of 1, j plus 1 becomes a of 2. Now we compare these elements. If a of 1 is greater than a of 2, then elements are swapped. If this condition value is false, elements are not swapped. After the j is incremented, j becomes 2, 2 less than 4, condition true. Now a of 2 is compared with a of 3. Now a of 2 is compared with a of 3. Okay. So after this, if a of 2 is greater than a of 3, then elements are swapped. Otherwise j is incremented, j becomes 3, 3 less than 4, again condition true. So a of 3 is compared with a of 4. Now a of 3 is compared with a of 4. If a of 3 is greater than a of 4, then elements are swapped. Otherwise j is updated, j becomes 4, 4 less than 4, condition false. So how many times this loop is executed, beta? This condition is true for 0, for 1, for 2, for 3. How many times? 4 times. So in first pass, how many comparisons we require? In the first pass we require 4 comparisons. After this, I is updated, I becomes 1, 1 less than 4, condition true. Now j start from 0. Now in pass 1 again we compare a of 0 with a of 1. Now here n minus 1 sorry n minus 5 minus 1. No, 0 less than here, and I becomes 1. So 5 minus 2, 5 minus 1 minus 1, 5 minus 2 becomes 3. So here 0 less than 3, 1 less than 3, 2 less than 3. So how many? 3 less than 3, condition false. So how many times this loop is executed? This loop is executed 3 times. Okay. And in pass 2 we require how many comparisons we required? In pass 2 we required 3 comparisons. Okay. So in this way this will work. After this, after completing this both loops, we display the values of the resulting array. So I start from 0, I less than n, I plus plus, I simply implement the loop for displaying the array elements. So I write cout object for displaying the value. I write here a of I, and slash t is used for the tab space, and elements are displayed on the output screen separated by the tab space. So this is all about the bubble sort. So the thing is, now we discuss the time complexity. Now we discuss the time complexity of the bubble sort. So if you uh, analyze in the first pass, how many comparisons we performed? We performed 4 comparison, that is n minus 1. In the second pass, how many comparisons we performed? We performed 3 comparison, that is n minus 2. In the third pass, how many comparisons we performed? We performed 2 comparison, that is n minus 3. In a similar way, and in the last pass, how many comparisons we performed? We performed only 1 comparison, that is 1. That is 1. Okay. Now for finding the complexity, we will add all these comparisons. Okay. So now we discuss the now I explain what is the time complexity for the bubble sort. Okay. Now if you analyze here, in pass 1, how many passes required? N minus 1. In pass 2, how many passes required? N minus 2. In pass 3, how many passes required? N minus 3. In the last pass, how many passes required? Only 1 pass. Okay, this is the general way by which we write this function for finding the total comparison. Okay. Now if you add these series, now the formula for adding this series is, because these are the natural numbers, so for adding these series it becomes n into n minus 1 divided by 2. Why n minus 1? Because last element is n minus 1, so n into n minus 1 divided by 2. And the now time complexity becomes, the overall time complexity becomes, because it becomes n square minus n and divided by 2. And if we assume that in algorithms we assume that n has very large value, so if you divide n square by 2, it doesn't affect the value of n. If you divide this n by 2, it doesn't affect the value of n. So from n square and from n, from these, which one is the largest, which one is the maximum? N square is the maximum, so the time complexity becomes big O of n square. So this is the worst case complexity of the bubble sort, that is big O of n square. Now we discuss what is the best case complexity. Now the thing is, when we have the best case for the bubble sort, for the best case, if the best case is when all elements are in the sorted order. If your all elements are in the sorted order, if your all elements are already in the sorted order, then in this, how many passes required? We require 4 passes. Okay. But when we compare first element with the second element, swapping is not performed. When we compare second element with the third element, again swapping is not performed, because elements are already in the sorted list. So it means your inner for loop is not executed in this case, so only outer loop is executed. So that's why best case complexity becomes big O of n, and for average case and worst case, the complexity is big O of n square. So I hope all of you clear about the time complexity of the bubble sort. Now thanks for watching my video, and kindly like, comment, share and subscribe my channel. Thank you.